Hey guys, my name is Mr. Rafferty. I am possibly your chemistry teacher. Mr. Arrow might be your teacher. You're going to see videos made by Mr. Arrow and myself for both classes, as we're both teaching applied chemistry at the same time. So we're going to share some of the workload. Please feel comfortable asking either of us for questions. Even if we are not your teacher, we are here to help. So before we get started, this is going to be the format that most or all of our lectures are going to take place. So we will take notes in the distance learning portion of our course, and then we'll try to stick with labs and activities when you are in the building with us. Okay, so before we get started, if you do not have your green sheet packet out with you, pause this video, go get it. You cannot work through this video without your green sheet. So we're going to be taking notes on this packet. You should have got this on your first day in school. And we're going to start right at the top. So what is matter? Right. So in our universe, we can break down almost everything into two categories, either matter or energy. Right? And the difference between matter and energy is that matter has mass and it takes up space. So think about this pen, for instance. Right? This pen, if I put it on a balance, right, it would register that it has mass. And does it take up space? Of course it does, right? How many pens do you think I can fit in my pocket? Maybe 5, maybe 10, 20 if I have really big pockets, but I cannot fit 400 pens in my pocket because it does take up space. All right. When we're thinking of energy, we're thinking of stuff like light or radio waves or X-rays, anything that could be on that light spectrum. And then some stuff that might be above both of our heads that we just are not too familiar with. Those are the questions that you take to Mr. Arrow. All right, so you should have copied this down in that first box. If you feel like I'm moving too fast, that's okay. Hit the pause button, and I will wait for you. Obviously, right? You guys are in control right now. So, in our second box, how can we classify matter? So, matter can be broken down into simple or complex. All right. We're going to talk about mixtures first, right? Mixtures are a little bit more complex. It is when we physically combine, right, two or more substances. So some common mixtures or some very good examples would be something like chili. You can see all the different components of chili, but these components do not chemically combine with each other. They keep their own properties and identity. Another example would be Chex Mix, right? A pretzel is a pretzel whether it's in Chex Mix or out of Chex Mix. It does not change. Right? If we're talking about pure substances, and we want to add this to our box as well, it will include elements and compounds. Let me see if I can. Oh, sorry about that. Elements and compounds. Hopefully that is still in your view. I do see that it might be cut off from the bottom. So pure substances, we bring down elements or compounds. Elements are what we find on the periodic table. We'll talk about them in a little bit more detail soon. Compounds are when we chemically combine two or more elements together. So we call these pure substances. All right, mixtures are complex or impure, and elements and compounds are pure substances. All right, so down at the bottom of page 1, we have our definition for a pure substance. And this is substances that have a definite single set of properties. Right? These properties could include, but are not limited to, boiling point, melting point, and density. Think about a piece of gold. Right? You may have seen videos on the History Channel about the gold miners. Anywhere you find pure gold, whether that's in Africa, Australia, Canada, it's going to have the same properties. So all gold, as long as it's pure, will melt at the same temperature. And all gold, right, as long as it's pure, will have the same exact density. All right, so specifically now we're going to speak about elements. So this is down at the bottom of page 1 still. We're going to fill in each of these 4 squares. So elements cannot be broken down anymore. We can break down mixtures, right? I can take out the pieces of my Chex Mix and separate it into different components. We can even separate compounds. It's more difficult. We have to do it chemically, but we can do it. But we cannot break down an atom. This is the smallest piece of matter that we can think of that still retains the same properties. All right, so in the top left, we should write down that it can't be broken down anymore. We find it on the periodic table. Over 100 elements exist, and we represent them by a symbol. All right, and I want you to take a second, and on your green sheet where it says represented by a symbol, all right, I want you to make a note that the first letter of every symbol should be capitalized. If there is a second letter in that symbol, it should be lowercase. Okay, and you will see some examples later. So every time you see a new capital letter, you have a new element. All right, like I said, if I'm moving too fast, just pause the video, take the notes, start it up again. All right, so turn to page 2. Pure substances. Now, pure substances compounds. So we're going to fill in these boxes. Compounds are formed by chemical combination of 2 or more elements. Right? All compounds are pure substances, and we represent them by chemical formulas. But the difference between a symbol, which we relate with elements, and a formula, which we relate with compounds, is that a compound has more than one element, so more than one symbol next to each other. And remember, like I said, every symbol for an element will start with a capital letter. So if you see more than one capital letter, you know you have a compound. We'll get to that in a little bit. Okay, so make sure you have that down. Here are some examples. All right, so examples of compounds. We have sodium chloride, which we call table salt. When we put this in a chemical formula, it is NaCl. The Na is our symbol for sodium. Cl is our symbol for chloride. Cl may confuse you sometimes, all right? Because we do have elements on the periodic table that are just a capital C and just a capital I. We in this class are never going to put those two together, right? Carbon and iodine, we're not going to put those two next to each other. So anytime you see something that could be capital C lowercase l or capital C capital I, it's always going to be the element chlorine or the ion chloride. Right? It's never going to be carbon and iodine. So just for future reference, and you can always ask and we can clarify it for you, but we can see that this has 2 elements because there are 2 capital letters. N and C are our 2 capital letters. Chalk we call calcium carbonate, which should be CaCO3. Right? Ca represents calcium. Now carbonate is another compound. So CO3 is our carbonate, which is made from carbon and 3 oxygens. Alrighty. And last but not least, we have carbon dioxide, also known as dry ice when it's in its solid form. This is CO2. And what this means is we have 1 carbon element and 2 oxygen atoms chemically combined together. Alright, so a little bit of summary for the bottom of page 2. So elements are made up of the same kinds of atoms, and they are found on the periodic table. Compounds have 2 or more atoms chemically combined, 2 or more different types of atoms, and they're written as a formula. All right, so let's try some practice here. All right, let's see if we can identify stuff as an element or a compound. All right, so shout these out even if you're by yourself. So CH4, what would we think? Would that be an element or a compound? Right? And I'm on the top of page 3 here, so make sure you write these examples in the correct side of the table on page 3. So I see we have CH4. I see 2 capital letters, right? That C stands for carbon and the H stands for hydrogen. There are 2 different types of atoms, 2 different elements, so we know this is a compound. Next one, this does not say Na, it is Na. Na we know is sodium. Well, I know, you will know soon. All right, and I only see one capital letter, so that means it must be an element. All right, and we can find that symbol Na on the periodic table. H2O, right, commonly known as water. I see that there are two different elements, right? We have a hydrogen and an oxygen chemically combined together, so it must be a compound. KNO3. K stands for potassium, N is nitrogen, and O is oxygen. And that's three different types of atoms. So we know this has to be a compound. Xe is xenon. All right. I only see one capital letter followed by a lowercase letter. We can double check with the periodic table, and you would see that xenon is found on the far right side of the periodic table. This is an element. CO, all right, and we want to pay attention to the letters here. All right, so I have a capital C and a lowercase o. So there's only one capital letter. This must be an element, and it is the element cobalt. I apologize for the bells. That should be the last one in this video. All right, now this one looks very similar. We have a capital C and a capital O. Because we have more than one capital letter, that means that we must have more than one type of atom. Right? More than one element, or two or more elements chemically combined together. So here we have a carbon bonded to an oxygen. That makes this a compound. Right? Looking at these two examples, cobalt and carbon monoxide, right, CO and CO, the big key here is looking at the capital letters. If you see only one capital letter, you know element. If you see more than one, you know compound. O2. All right, so here I have two atoms, right, two oxygen atoms chemically bonded together, but they are the same type of atom. Okay, so this belongs on the element side. Right? It's okay, you could have O14 and it would still be an element because it's all the same type of atom chemically bonded together. Alrighty. Cl2, very similar to O2. This is only one type of atom, right? Even though there's two atoms, there's only one type, so it belongs with our elements. Alright, so I did a little explaining of this already, so I did spoil some stuff, but let's roll through this quick. So what's with O2 and Cl2? So even though they have a subscript, and that's what we call this little number down here, they are still considered elements. We have 7 elements on our periodic table that are found in nature as two atoms bonded together. All right, so when we find them in our world, right, they are almost always bonded to each other. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Right, we call these our gins and our ides. So anything that ends with a GEN or anything that ends with an INE is going to be what we call diatomic. Okay, you do not need to memorize these. This is just for your information. Okay. Now I'm going to stop right here. So as long as you got all your notes, awesome, good work. We made it through our first lecture together, and we will start part 2 of section 1 quite soon. So I will see you in a couple minutes or hours or days to work on the counting atoms portion. Alrighty, let's make this a great semester. See ya.